Hi, how are you doing? Welcome to this video and this channel. And in a previous video, we learned how to differentiate implicit functions. So I want us to introduce another method, that is differentiation using parametric equations. If you have not checked my previous video, check them on the link shown here. Also remember to subscribe to the channel, leave your question in terms of a comment, and also remember to like the video. Now let us get to the task. Differentiation using parametric equations. Okay, sometimes you may be required to get derivative of y with respect to x, or derivative of any other variable with respect to another variable, but we are using a third variable. Say both y and x are given in terms of another variable. Both y and x are given in terms of another variable, say t. That variable is our parameter, and these two equations are our parametric equations. So there are quite a number of methods of differentiation. Now it's important that whenever you check a question, you just directly you can be able to tell the method of differentiation you are going to use. Because in most cases they do not tell you the method to use. It's up to you to notice a certain problem should be differentiated using a certain method. Let us discuss this method using an example. Example, we have this diploma in building and civil. Diploma in building and civil, and this is June July 2020. We had used this past paper in the previous video. June July 2020. It was question 3. We did Roman 1 using implicit method. Now we are going to do Roman 2. Roman 2. We are told determine the derivative of the following functions. Determine the derivative of the following function. We did part 1. Now part 2. We are given two parametric equations. X is equal to t to the power 5 minus 4t cubed, and y is equal to t squared. So x is equal to t to the power 5 minus 4t cubed, and y is equal to t squared. So you can see both x and y are given in terms of another parameter t. They are given in terms of another parameter t. So these two equations are what we call parametric equations. Now we are expected to get derivative of y with respect to x. We are supposed to get derivative of y with respect to x. So how do we go about it? So what we are going to do, we will differentiate these two parameters, or the parametric equations. We're going to take x, which is a function of t, differentiated with respect to t. What do we get? 5 t to the power 4 minus 12t squared. We're also going to take y here, differentiate with respect to t. Because here in this case y is a function of t. This will be 2t. But we are supposed to get dy dx. What dy dx? you can remember what we did when we were learning about chain rule. We said dy dx can be given by dy dt times dt times dt dx. So we have dy dt, this, but we do not have dt dx. Instead we have dx dt. So in this case we have to find dt dx, which is simply the reciprocal of dx dt. So dy dx will be equal to dy dt, which is 2t, times dt dx. dt dx is the reciprocal of dx dt. So it will be times 1 over 5 to the power 4 minus 12t squared. Minus 12t squared. Which, so dy dx is equal to 2t all over 5t squared, 5t to the power 4 minus 12t squared. So that is it. It's pretty simple, but challenge will be if you are told to find the second order derivative. Actually, in most cases, you'll be told to find the second order derivative. In this case, you are just expected to find the first order derivatives, but I'm also going to go ahead and show you how you would go about it in a situation whereby you are expected to get the second order derivative. You are told to get the second order derivative. Here you are adding yourself an extra question. It was not part of what you are supposed to do. Second order derivative, it will be equal to the derivative of the first order derivative, 2t all over 5t to the power 4 minus 12t squared. That will be it. The derivative with respect to x of the first order derivative. Actually, I should have put it like this so that it's easier for you to see it. The second order derivative of y with respect to x is the derivative of the first order derivative, the derivative with respect to x of the first order derivative. But what is the first order derivative? We have just found it. So the first order derivative, this one now, is this 2t minus, not 2t minus, but over 5t to the power 4 minus 12t squared. So we'll be finding the derivative with respect to x of the first order derivative. But notice, we are differentiating with respect to x, but we don't have any x here. It's all, this variable is t. But remember, x was a function of t. X was a function of t. So we don't say this is constant. We cannot say this is a constant because x is also a function of t. So how do we go about that? To get that derivative with respect to x, 2t all over 5t to the power 4 minus 12t squared to be equal to derivative with respect to x, not with respect to x, with respect to t, 2t 5t to the power 4 minus 12t squared by this time loud, we multiply with that dt dx. Then we multiply with the dt dx. We have cancelled out this dt will be d dx. This is what we wanted to get here. Notice, to differentiate this, you must use to differentiate this, we must use, I think I'm going to remove this. We must use quotient rule. I think at that point, I don't know whether you need the rest. Okay. Notice here you must apply quotient rule. Quotient rule states if you are differentiating y, which is u over v, if you are given y is a ratio between two functions or two terms, then the derivative is you take v the it is, differentiate u, minus you take u the it is, differentiate v, or over v squared. Or over v squared. So this one will be v, take it the it is, this is 5 t to the power 4 minus 12 t squared, differentiate u times 2, take u the it is 2t, differentiate v, it is 20 t to the power 3 minus 24 t, or over 5 t squared, not t squared, t to the power 4 minus 12 t squared because it's over v squared times. Now there's something I removed, we needed. I have to go back to the paper and remind myself because I have a limited space, that is my challenge. So here you're going to multiply with 1 over 5 t to the power 4 minus 12 t squared. So that's how we can try to simplify. I don't know whether it will be possible to simplify beyond that. I think this one is not possible to simplify any further, but we can factor out the 2 into 5 t to the power 4 minus 12 t squared. Yeah, I factored out at 2. Yeah, I factored out at 2, so it is this 2. I'll open with the negative t, negative 20 t to the power 4, open negative 20 t to the power 4 plus 24 t squared over, multiply this and this the denominators, it will be 5 t to the power 4 minus 12 t squared. This was power 2. They are similar, 5 t to the power 4 minus 12 t squared, 5 t to the power 4 minus 12 t squared. So we are multiplying, we are going to add another term, which is now 2 into, let us simplify this. These are positive 5, these are negative 20, that is negative 15 t to the power 4. These are negative 12, these are positive 24, plus 12 t squared. Okay, I think that is it, because this has reduced to 15, this has reduced to 12, or over 5t power 4 minus 12 t squared power 3. It's not possible to reduce beyond that point, so in this case we deviate to that. But notice this one we had not been told to do it, but it was important for me to show you how you can go about solving a second order, because a lot of time you'll be given a second order. So that's why I had to go to that extent of showing you how to solve a second order. That is it. I believe I've not wasted your time in this video, and certainly not in the next video. So remember to subscribe to the channel, share my videos with your friends who are doing engineering courses, and also always remember to like the video.